Hey guys, welcome back to the Cloud Chat, uh, hopefully weekly podcast. And today we have a bunch of stuff to discuss about what happened over the last week in cloud computing, as well as generally in engineering as well. Chamath, what do you think?
Yeah. So when we started doing this podcast, then we figure out there's more and more news coming up. If we start looking into some news, like it's always there. For example, this week it's going to be like we had some interesting news and sort of very groundbreaking news as well, right? Along the week. So yeah. So this is our podcast, third podcast. So let's get into it, right into it then, David.
Exactly. So, just to give a sneak peek, we have some stuff about the elephant in the room, which is Facebook, as well as some other stuff as well that actually happened in software engineering. So dive into it, and let's start off with Facebook. All right. So this is basically about the outage that happened on October 4th. Basically, as I'm pretty sure everyone knows, Facebook just disappeared off the internet, and it was no longer part of the internet, the entire Facebook backbone. And because of that, Facebook, WhatsApp, and Instagram, all of them were down. And let's just sort of discuss a bit about it, and let's see if there might have been something better that they could have done in terms of processes and stuff like that. Chamath?
Yeah. Yeah, David. So I think this is what we can really call a global outage. So I think this has affected like so many like different levels. Sorry. So for example, our parents and everyone sort of knew that Facebook was down because this was like a very huge outage. It's not like a 5 minute downtime or something very basic, but this affected the entire I think the huge population, the
Exactly.
entire
So
population, right? Yeah.
exactly. So I mean, the only way I stay in touch with my parents as well is via WhatsApp. So when this went
Yeah.
down, they were like, okay, how else are we supposed to call each other, and how else is this supposed to
Yeah.
happen? But
And if you
on
have
another,
Facebook, then it's Messenger.
yeah, exactly, and then it's Messenger. And the other the interesting thing about this is that there are very few planet scale systems, I would call them, in the world. Google is one of them, Facebook is another, and obviously Amazon as well, AWS. But when you look at what actually happened here, you can see an entire planet scale system sort of go offline. It's like a huge chunk of the internet just went offline at that moment, and I think that had a lot of ramifications all over the place. I think one of the best things that happened out there too was that Twitter got a lot of traffic there as well, and they had issues scaling up their network as well to sort of handle the traffic there because Facebook was off. Yeah, so let's just sort of dive into this sort of post-mortem, I would say,
So
about
this is
what
the official
exactly.
official
Exactly.
document from Facebook itself.
Exactly. This is
So
the
yeah,
official one. Yeah. So this is sort of like it's sort of like a postmortem, but it's not really. It's not very technical, but basically what this says is that um, the outage was triggered by the system that manages our global backbone network capacity. The backbone is the network Facebook has built to connect all our computing facilities together, which consists of tens of thousands of miles of fiber optic cable crossing the globe and linking all of our data centers. So those data centers come in different forms. Some are massive buildings that house millions of machines that store data and run the heavy computational loads that keep the platforms running. And others are smaller facilities that connect our backbone network to the broader internet and the people using our platforms. When you open one of our apps and load up your feed or messages, the app's request for data travels from your request to the nearest facility, which then communicates directly over our backbone network to a larger data center. That's where the information needed by your app gets retrieved and processed and sent back over the network to your phone. I think if we consider this in sort of like a LAN perspective, as something that's on your sort of local network, I would say that the data center would probably be like your personal computer, and these little other sort of facilities that facilitate the connection, the routing between Facebook's backbone as well as the internet would more or less be like your router. Is that right?
yeah, yeah. So they mean yeah, one of the most important things they have highlighted in the first two sections is like mainly okay, this is a network issue, right? So this is basically they had clearly like clear cut said okay, this is network issue. It's not like a hardware failure or sort of like what do you call
No,
application bug or something like that,
exactly.
right? So I think they wanted to like highlight that part because it's basically their network. Let's say someone plugged the wire out. Just imagine that sort of
Exactly.
thing.
So,
So
so the thing is, even if this was sort of a software issue or a hardware issue, it would have been very easy to recover. I mean, people wouldn't even have probably felt it because with with hardware with software stuff, we have these different sort of canary deployments. As soon as you sort of figure out that a canary is failing, you can just roll over to the previous build and you're completely fine. There's nothing that much that happens with that. And if it's a hardware failure in their data centers, there's a lot of redundancy involved that
yeah,
allows these machines to keep running
if if
constantly.
it's a hard disk, Damien, you can have like RAID 1, RAID 10, sort of like there are like so
Yeah.
much failovers for them. Like if
So
this fails, then we can move to the other.
sorry. So it's not just that, but also the concept of VPSs, virtual private servers. So I mean, it's most probable that Facebook sort of scales up all their containers, right? So if they have one sort of service, say they have the Facebook monolith, the PHP monolith, you have this monolith, but it won't be running on one computer. It's going to be running on thousands and thousands of
Thousands of,
nodes.
yeah.
So even if one node fails, it's completely fine. Your load balancer will just detect, okay, there's an unhealthy node. It'll just reroute the traffic to all the other healthy nodes. So it's like it's very minimal. I mean, you might sort of get like a white page or you might get a loading issue, but it's the effect is very very minimal when it comes to sort of even hardware failures. Um, Software failures, as I said before, it's just a matter of rolling back. And we
Yeah.
also have like automated tools to sort of detect. Like you can have stuff like Linkerd and stuff like that, and you can configure them so that if the failure rate of your that specific version is very high, it'll just automatically roll back, and it'll sort of deploy the previous version
Yeah, and
to
it's
it
like more like
basically. To
regional, right? I mean, let's say the computing power is sort of regional as well. Like for one region, it would have a separate set of like updates rolled out separately. So yeah,
correct.
if we go a bit down on the article, I think they had mentioned like how it happened. So this was the source of yesterday's outage. During one of these routing maintenance job, a command was issued with the intention to assess the availability of the global backbone capacity, which unintentionally took down all of the connections in our backbone network, effectively disconnecting Facebook data centers globally. So that's a very powerful few lines of words.
Exactly. So this is basically
Yeah,
the root cause analysis. So
yeah,
what they're basically saying here is that during one of the maintenance jobs in one of their maybe data centers or one in one of their other offsite locations, one of the maybe engineers or someone just sent out a routine sort of command just to check the availability of the network. It's kind of like a ping, I guess. I don't know what command they use, but it's probably like internal sort of protocols and sort of software that they have. But I would sort of say it's kind of like in the region of a ping, just to see, okay, is everything up and running, and maybe to get some stats on the capacities and
yeah,
speeds of the network. But probably sending this command
yeah.
seems to have completely screwed up the entire sort of all their routing tables here. And
So if you
what's
see the last
interesting to me
line,
is the part after that, which is our systems are designed to audit commands like these to prevent mistakes like this, but a bug in that audit tool prevented it from properly stopping the command. So they audit their commands, but there was a bug in that tool, and they probably need another audit tool, another layer of auditing behind that just to stop stuff like this from happening. But I think, okay, so what I see here is this most probably is a software issue. So this is sort of something that could have been prevented by proper testing and stuff like that, because this audit tool appears to be some sort of service that runs in the cloud, right? Because it
yeah,
needs
it
to
can be
sort
like
of
an internal
constantly.
tool. Yeah,
Exactly. So it's something that runs internally in their sort of backbone and in their data centers. So basically, this audit tool had a bug that prevented it from stopping a catastrophic command to shut down basically the entire Facebook backbone. And I think at the end of the day, I think so. I'm not a Facebook engineer, but I think in my experience that having more tests and more testing scenarios could have actually caught this and could have prevented this. So at the end of the day, I think the fault is on software engineers, not network engineers.
Yeah, that's true. So yeah,
Um,
Devin, one more thing to like realize with this, like the same paragraph is sort of uh, like it's a global, what do you call it, global network, right? So if an audit is happening on a global network, that's so like I'm not sure like how to put it into words. Like we usually do, like let's say, okay, we only test the first 2 wires, then we do the next 3 wires, like something like that might have prevented much of the damage, I feel. But I'm also not a Facebook engineer, but I'm just like thinking how to sort of let's say if it happens to our product, how are we going to sort of recover that sort of
exactly,
thing. So if we are doing such audit, we have to make sure we are doing like a very, what do you call, isolated manner. Okay, this is
exactly.
independent. If this, yeah. So
Yeah,
Messenger
that's
and
true.
Facebook, sorry, WhatsApp, Facebook, Instagram. So you could have like sort of independent three backbones, so one won't like.
That is so true. Yes. So
Yeah.
I think they are actually it's more about economies of scale and putting down costs. So actually having
Okay.
maintaining three separate network backbones for these three
Each.
products, even though they
Yeah.
are really huge, would cost a lot, and the maintenance would also be very high. I think
So
it's
it would
much
triple their
more
cost.
exactly. So it's kind of like AWS. So say AWS goes down, the AWS routing system, the Route 53 just crashes, everything that is on AWS will stop working. So I think,
Yeah.
I mean, it's fine because I understand why they do this. I mean, even if I was in their
Yeah.
position, I would do this, and a lot of companies do this nowadays. We all depend on stuff like AWS, GCP, Azure, and stuff like that.
Yeah,
It
I mean, this is actually not like it's not like blaming the Facebook team. It's more like learning from that, right? Like we all need to
exactly,
learn what happened here from there. Yeah.
exactly, yeah.
So.
So
Hmm.
yeah, that's quite true. But I do think that there's another issue here. If you just read between the lines, it says here that during one of these routine maintenance jobs, a command was issued with the intention to assess the availability of the global backbone capacity, which unintentionally took down all the connections in our backbone network. So what I read here, what I understand here is that the command was actually supposed to be doing this. The command was actually something that actually maybe reset the routing tables and the BGP rules. But what happened here, what I think could have prevented this on a much more like a higher level would have been access rights, um, sort of, uh, ACL lists and access rights sort of mechanisms. So I think maybe that is also something that they would be looking into, reducing the amount of access rights that each person has, and maybe having a catastrophic sort of a command like this, like a red button, would probably be on the Mark Zuckerberg sort of level, not on the level of a
So yeah.
network engineer.
So we so we know there's a kill switch for Facebook.
Exactly, exactly. So
Yeah.
I think I think if we sort of take a step back and take the abstract of this, there seem to be there seem to have been issues in access rights in whatever sort of software they used here to assess the availability of the backbone network. There seems to be an issue with their audit tool, a bug in the audit tool, which properly stop the command. And I think at the end of the day, both of these are basically faults of software engineers, and it's basically like lack of access rights, lack of testing and stuff like that. And these are stuff that actually um, should and can be made better and can be improved the more mature you become as a software engineer, in my personal opinion.
Yeah. So so I mean, yeah, like if we go a bit down further, so the outage was so long, so we need to figure out why it was so long, right? So if it's a small outage like this, if we can quickly replace, but in this para where they have mentioned all of this happened very fast, and as our engineers worked to figure out what was happening, they had to face two obstacles. So one was basically they need to access the data center through the same network, which was down already, so they couldn't access that. And the second one is the tools they have made like to investigate, sort of they can't access that through the same network, right? So both software and the connection is all down for them.
Yeah.
So, and then they had mentioned, I mean, in the second part, I think they had to go on site. So the engineers had to go on site, and it's so secure that it would take so much time to get approval and sort of like go to on site sort of data centers like physically. So that's, I think, the main case here, which
So
took so much of time.
what I actually heard was I can't remember whether this was on CNN or something like that. But I heard what I heard was that even the key cards were not working. So they couldn't even scan a key
Oh,
card, and their biometrics were not working. They couldn't even get in through a door. And you have to understand sort of the security in data centers. They have fire prevention systems. They have systems to prevent unauthorized use, unauthorized access, and stuff like that.
Disasters. Yeah,
Disasters
so
and all that.
so
It's like a
yeah.
nuclear bunker. So I mean, if your key doesn't work to your nuclear bunker, what I heard from these sort of, these are basically rumors. These have not been verified, but they basically had to take chainsaws and they had to take drastic measures to cut the doors open and sort of get in there and access the servers themselves. So
Yeah, I mean that can be true because they had clearly mentioned the physical and security sort of like the level of physical security. So they had, so I mean obviously something like this level can happen because it's a network, right? So if it's a key card, it should go to some network and say okay, true.
exactly.
uh, so yeah, I mean this, I think they should make an after movie of this what happened. So it would be really nice, like a whole next level thing, right? It's like movie
It
material.
would.
I feel like.
It would.
uh,
I am pretty sure. So this is something that has come from my experience of sort of dealing with code reds and stuff like this. Basically catastrophic failures. In these short hours, in these 2 to 4 hours, if you are a junior engineer, you you sort of get the experience and the knowledge to become a senior engineer. I mean,
yeah,
the
just one
amount
event
of
is enough.
pressure, exactly, the amount of pressure you're under, the things you start to learn, all the things from university, from all the stuff that you have done, everything just comes into your brain and you start basically working like a sort of quantum machine, trying to figure out, okay, what's next, what should I do, and stuff like that. And people just perform at the max when stuff like this sort of happens. And this is from my personal experience, but this is like a basically like a like a evolutionary sort of process
Yeah,
when you're there as an engineer. I mean, everybody just takes a step up because nobody has sort of faced something like this before. Nobody
something.
knows
Yeah, because this
who to look
is.
to.
Yeah, exactly.
It's crazy.
So I think Damien. So I think this article, like I mean, we would recommend our viewers to sort of and sort of have a look in this article if you like. This is just like non-technical mostly, like just the story of what happened. And if you go into bit technical, Damien, shall we go to the Cloudflare article, which had the same information,
Sure.
sort of technically? Yeah.
Yes. So
Um.
this is a Cloudflare article. I think it was released one day before the official Facebook sort of the press release. And this is basically a Cloudflare article from Celso Martino and Tom Strix, titled "Understanding How Facebook Disappeared from the Internet." And so
So the first part
uh,
of that is so fun, right?
this is
The first
fine. Yeah,
section.
this is exactly what I thought as well. Um, so it's basically Facebook can't be down, can it? We thought for a second. Today, so according to the article, so today at 3:51 UTC, we opened an internal incident entitled Facebook DNS lookup returning server fail because we were worried that something was wrong with our DNS resolver 1.1.1.1. So just some background on this. Cloudflare has its own sort of DNS system similar to Google and the rest, and OpenDNS and the rest, and that is basically 1.1.1.1. And whenever people were trying to access Facebook via their DNS servers, it was always returning a server fail error. And because of that, Cloudflare was sort of getting panicked, and they thought there was an issue on their side, because obviously Facebook,
Facebook can't down.
such a planet scale system cannot go down, right? And because of that, they opened an internal investigation. And as they were about to post on their public status page, they realized something more serious was going on. And so let's continue with the quotes. Social media quickly burst into flames, reporting what our engineers rapidly confirmed too. Facebook and its affiliated services WhatsApp and Instagram were in fact all down. The DNS names stopped resolving and the infrastructure IPs were unreachable. It was as if someone had pulled the cables from their data centers all at once and
Yeah,
disconnected them from
that's
the
what.
internet.
Yeah, that's I think that sums up, right, what we just discussed in the other article. Pull the
Exactly.
cables, right? It's something happened similar.
It's a
So
kill
yeah,
button.
it's nice. Kill button. Yeah. um,
So then they continue on to say this wasn't the DNS issue itself, but failing DNS was the first symptom we'd seen of a larger Facebook outage. How is that even possible? So the update from Facebook. So this is basically about what we read before, but now on to what we saw from the outside. So BGP. So BGP stands for Border Gateway Protocol. It's a mechanism to exchange routing information between autonomous systems on the internet. The big routers that make the internet work have huge, constantly updated lists of the possible routes, which can be used to deliver every network packet to their final destinations. Without BGP, the internet routers wouldn't know what to do, and the internet wouldn't work. So basically, what this means is BGP is sort of this ancient sort of protocol that's been around from the start of the internet, that basically takes all of these little sort of LAN networks and MAN networks and sort of connects all of them together into these WAN networks, or basically the internet as we know it. So it's with BGP that servers as well as your laptop or your personal computer actually know which route to actually take. So once a packet is sent from your computer to your router or to your Wi-Fi router or whatever, and onto your ISP, they all use the BGP protocol to identify, okay, where next should I go to? What's the next step I should take? What route is sort of the closest route in order to reach my final destination? And what happened was that Facebook's BGP sort of
Which connects to the outside,
broadcast, so
yeah.
broadcasting systems all just shut down. Basically, all their BGP rules, their routing tables, all just were all sort of removed. And because of that, what happened was that the rest of the internet. So what happened was basically the Facebook, the internal systems, their routers and their network switches were not sort of broadcasting out to the rest of the internet that, okay, this is where you can find us. This is how you can get to us. And because of that, none of the other routers and none of the other sort of servers out there could actually identify, okay, this is the route that we need to take to Facebook. And sort of that's basically why the entire thing sort of failed in the first place.
Yeah, I think this article has some nice graphics and sort of like how it resolves them in just that one. So that's how you sort of communicate from one. I mean, like hop to hop, you just have to jump. And then the little bit below them, they had mentioned like network not in table. So basically, when it's doing a lookup for the IP address of, I think, Facebook resolve, like it's trying to resolve the DNS or like where to go to next. So it says network not in the table.
It's not in the root table.
Yeah, root table. Yeah. So so that's mainly it, right? I mean, it's not like a major. I mean, it's not like a huge magical thing that happened that made made Facebook down. It's something very basic, but has so much of power to do something which is catastrophic.
Exactly.
Yeah. So I mean, I think what we were talking about is mainly the like show IP BGP of the Facebook IP address, and it just says there's no entry in the table, right? So imagine something like that happens, and sort of how can you get notified as soon as possible? For example, if it's a internal issue, internal server issue, we can get a Slack notification, something like that. But if it's happening internally, anyways, I mean internally as in network level, you won't get any notification, right? That's the first thought I had in mind. Like how can get like Facebook get notified from this issue, because it's
I don't think they can. So here's the thing. I think all of their monitoring tools are also sort of on their internal network.
Yeah.
But on the other hand, what I have used is stuff like New Relic, Datadog, and stuff like that. So these are all like outside the network that we are on. So even if I'm hosting on AWS, I have my own sort of private sort of network within AWS. That no one can sort of come in and access. If I have my own VPN sort of set up there, that I wouldn't feel safe hosting my own monitoring tools inside there, because I wouldn't know if people would still be able to access my publicly available routes. So what I would go for is I would go for third-party sort of services like Datadog and stuff like that basically do synthetic tests and synthetic monitoring on your website. So they actually go and they poll and they check, okay, is this up? Is this up? Is this up? And as soon as there's an issue, it sends a message directly to you. I think what Facebook has here, one of the issues they have is they have all their eggs sort of in one basket. All the monitoring tools, all the recovery tools, their diagnostic tools, their audit tools, everything is sort of within the same network here. And I think what should actually happen is they should sort of be able to break it away, the same way that we sort of separate our AWS accounts. So for example, if you have sort of an infrastructure account which has sort of all our infrastructure stuff, CI/CD, logs and stuff like that, that would basically be another account. That would sort of be like a root account. And we would have separate sub accounts for all the other stuff that we do, all the teams that we have and stuff like that. I think not on the account level, but basically on the network level, they should have maybe a separate network that is able to sort of, come in and sort of be able to recover, that has the services and all the tools they have that should be able to come in and recover this other main network that they have all this stuff going on. So I think
Yeah.
what's happening here is they basically, I mean, they have all the eggs in one basket, and
Yeah. Again,
when the
David,
link to that basket breaks, they're screwed.
yeah. And again, David, this is something like I think no one never expected. Like I mean, even let's say all the network engineers would have seen like this is the perfect way, right? Like once the systems are working, it should be the perfect system and highly scalable, efficient, everything. So no one would dare to like change that system if it's working well for the past, let's say, 10 years. Who would go and say, no, we are going to take this out and put the router in another data center or something like that. So, um, so yeah, it's very, I mean, that's how we get comfortable with our sort of our infrastructures, right? Usually when we get stick to something, it's very hard to sort of get out of it, infrastructure level mainly.
That's
Um,
quite true, but I also think that this is sort of the first time that anyone has experienced sort of an outage like this. An outage because of this. I mean, let's face it, all of this was basically done by Facebook's own internal systems, and they depend so heavily on them
yeah.
that it's sort of like, how do I put this? So, who polices the police is sort of what this sort of comes
It's like
into.
internal failure, not
Yeah. So,
nothing to do
so
with the sort of
who sort of oversees their internal, like, what's the internal system behind the internal system that looks into all this stuff. So I
yeah, they
think it's
should
a
get
good learning point for
yeah.
everyone.
I think David, this is more like the every like the big companies need to work together. Let's say Facebook team would go to Google data center and see like sort of like support in together. I mean like who's going to look after each other sort of thing. So for
I,
example,
I,
if
I mean
Facebook
that's
goes
true.
down,
I mean
uh,
that's true. It would be great if they had a backup plan. Like
cross
if they
sort
had,
of cross
I
team
mean,
thing.
yeah, even maybe a very small sort of containerized setup on Google servers, on AWS servers, maybe a very small sort of ECS cluster that's ready to go if anything happens to their main
Happens, yeah,
backbone.
yeah. And
But
same with Google, right? So like if their servers or like if their Solr goes down again, it's like the global internet again. So uh,
here's the thing: it's sort of like the pride that you have.
that's sort of
So
the
I
okay,
am
we are doing
Facebook.
this. This is mine.
I am Facebook. I am Google.
Yeah.
No way am I going to put my stuff on other people's servers.
True.
We have our own stuff for that. It's sort of the same reason why AWS was created. So that I mean, AWS was early internal. It was only hosting like Amazon, all that stuff,
Yeah.
until this started to pursue it as a business model, and sort of give it out for other people as well. But
Yeah.
at the end of the day, I think it's it's kind of like the pride you have.
Yeah.
You don't want to go
Because
to another person.
yeah, you you build like $1 billion companies, and why should you should depend on another $1 billion company?
Exactly.
It's something. So Damien, the key thing I'm like always like it's coming to my mind is like things like this. I mean, let's say what I said, like combining, like joining forces together. So for example, in this telco industry, earlier, like those past days, like back in the like let's say 15 to 20 years back, they all had their own sort of towers and things like that. Then they thought, okay, no, this is not going to work. So they started sharing, right? Okay, if one ISP is coming, we'll share the what do you call the tower, something like that. So it's very simple. It's not nothing sort of like breaking. But I feel like it's different in this tech domain again. But
Yeah.
that's how I think those guys actually played a good game, like reducing the costs, reducing the sort of outages, because one guy is shared on another guy's tower, and let's say that guy owns another tower far away, and it would be shared with the other ISP, so something like that. It's very sort of
I think this also comes down to like they might have other concerns as well. So, for example, would AWS really trust having servers alongside Google as well in the same data center? Because say there was some malicious actor who sort of injected code into
yeah,
Google and basically made all the Google servers just blow up. AWS would also be
yeah,
affected by that, right?
yeah. So what I
Um,
mean is mainly they make for like sharing the data. It's let's say a team of 10, and every big company goes to the other teams, and it's like a competition. So you are like like a hackathon sort of thing.
it's like
You
a
go to the other company
Y
and try
tech
to blame
project.
them. Yeah, yeah. Because end of the day, otherwise you can't get someone else from outside world and sort of go and show, okay, this is our data center, because they won't know anything what's internal, right? It's all internal tools and software mainly.
That's true.
Like
I mean, I think that's also the reason why this why they don't have sort of this auditing from external companies as well
external, yeah,
coming in.
yeah,
So,
yeah,
I mean, these are, let's face it, this is all $1 million products, not even
billion.
million, $1 billion products. Because let's face it, it's not just Facebook.com, right? They have internal systems, they have AI software. If you take Google, I'm pretty sure I saw that they were working on some quantum computing stuff, and all this stuff. So I'm pretty sure they always want to have the edge over the other
Yeah,
person. So um, I mean, like, seeing how companies work and how competitors work over the past years, I don't
yeah.
think that would happen anytime soon,
Yeah.
to
So
be
then,
honest.
yeah, so let's scroll a bit down. I think they had some nice graphs in this page. So, yeah, this is the second one. Yeah. So this is that one? No, not this one. A little bit down, right? So impacting other services. So the impact Facebook caused on other services. So just a bit down,
Um,
further down. Oh yeah, that graph, little bit down. Oh yeah. So this one. So this says queries for websites like Twitter, Signal, Telegram, TikTok. So once during that peak time where Facebook outage happened, so this is the impact of the other people's sort of services, right? So can you see like the times? Like it's more like 1.8 times higher traffic. Let's see if they had 100 million traffic, it's like 200 million traffic.
exactly. I think I remember seeing somewhere that sort of Twitter also had some issues scaling up their stuff. So if you just go
Because no
to
one would expect, right?
exactly. So let's see, Twitter scaling issue during Facebook outage.
So end of the day, what I think all these charts and graphs and all the heat map show us is mainly how dependent the world is. Anyways, like I mean the global infrastructure, how dependent it is to one another. So one person's failure is another person's failure as well. Like sometimes it's pulling everyone down together. um,
Exactly. Um, okay, I can't really find it, but
yeah,
I saw
I also
somewhere
felt like they
that
had a little bit
yeah,
down, and it was always fun to see how the social media channels of the like WhatsApp, Facebook, Twitter are playing around. So they're saying, okay, welcome everyone, literally everyone here, right? So some tweet was like that.
exactly.
uh,
It's yeah.
I
I
mean,
mean, you have
it's
to
always
capitalize on
like,
top, right?
yeah. I mean, it's sort of like it's good that these companies are not like very strict to each other. It's just making fun of each other's mistakes. um, yeah, I think we can. So yeah, this is the main story. I mean, for the entire week we've been seeing news on this as well.
Exactly. Everyone
So
sort of discusses about this.
discuss
Yeah.
this. So yeah, I hope we gave a good sort of in and
This
out
is
of this.
just
And
just 5 cents on on what happened.
so yeah, it's easy to talk, and it might be so hard for the Facebook engineers, even if someone sees a news article on this.
Yeah,
um,
that's true. That's quite true.
so Demi, yeah, one of the key takeaways I took personally and sort of to our sort of products is number one, the notification system. So for example, Facebook went down for 6 hours and not a single notification saying, okay, we are out, please wait, or something like that for in the application. So that's the first key takeaway. So for example, we implemented the SMS mechanism where, let's say, we use our status cake or some like status cake mainly to who which just like is up or down, site is up or down. So we would connect SMS gateway and trigger SMS alert, right? It's all independent from the entire system. So if we try to send an email, it's no point, it's in the internal network again. So something like that, I think Facebook should have done. Like even in the future, let's say they depend on Firebase on push notifications. Like I mean, something else outside Facebook in case of this thing happens, right?
Yeah.
So
I
they
it is again an issue with all their bugs in the eggs in the same baskets.
same,
Basically,
yeah,
I
yeah,
mean,
yeah,
it's crazy. I mean, I know I would love to personally, if I had a company as big as Facebook, I would want to have everything
in
under
the
my
same,
own roof
yeah,
because
yeah,
I wouldn't want like it going like all over the place and we
yeah,
have to depend on we have to pay fees for the people and stuff like that. But
yeah.
this
So
is this is a very good example of why you should have like backup systems
yes,
that use
yes,
software outside of what you have as well.
yeah. But what I thought is, they mean if they just had a JSON file in a S3 bucket just somewhere else, and it's just like true or false. Okay, so if it's false means something went down. So then you can put like internal message in there. Facebook app or something, like very simple mechanism. But yeah, it's always depending on how this politics works in terms of large corporations, right?
And I
And
also think like let's face sort of reality here. Like nobody really expects this to happen.
yeah, that's true.
Even when we develop stuff, when we do stuff, we never expect the entire thing to just crash
Yeah,
and just stop working. I mean, personally, like in all the companies I've worked in, we've all been using the AWS stack. So if something goes wrong with either some AWS region, they're basically EC2 servers or the routing or something like that. All of us are just like, okay, it's not us.
they just put the
Let's
blame.
just put an update on our status page saying, okay, there's an issue with with the infrastructure provider, and we'll just stay on the side
Yeah, that's the
because
easiest way to do the blame, right?
exactly.
Yeah.
Um,
All right. I think yeah, it's a good chat anyways on these sort of topics, which gives us some good feeling about the things happening. So I think this week we are talking a bit on negative stuff, right, David? Our next article is, I think, the
yes.
Twitch leak.
So our next article is actually another sort of big thing that happened, which was this is sort of the worst nightmare of any CTO or any sort of um, high executive in a tech company. It's basically a massive leak of source code in Twitch. So basically, what happened was um, somebody released a 125 gigabyte torrent, which includes the entirety of Twitch and its commit history. So I mean, if something like this happens, it's like it's super easy to just spin up a competitor of of that product, and this is
Twitch,
sort
yeah,
of the worst. I mean, it's not just that; it's also like when the service comes back online, you would basically have just opened your source code to like millions and millions of people out there, and even if there's one bad actor, if there's like one bad person in there. And they could find a bug in there that they could sort of exploit and gain
yeah.
control of Twitch once it's back up. It's horrible.
I mean, that's going to happen, right, Damien? So, I mean, security researchers, that's their job, right? To find vulnerabilities in the code. So, I mean, this is like next level, like a what do you call a gold mine for them. Like using
Exactly.
this level of scale,
So
it's a
it's not
production
just
grade.
it's not just security researchers. I mean, if a hacker or someone else comes through this, they don't even
Yeah,
need to hack. They just need to read the
read the
code is
code.
there for them.
Yeah,
They just need to read it and say, ah, okay, so there's an issue here. These guys are
yeah,
using an unsecured protocol. We can just gain control of their servers using this.
yeah,
And it's this is sort of one of the worst nightmares of being a software engineer or working in a company like this, because
yeah,
right now I believe what's happening in Twitch, like after something like this happens, you would basically be on like disaster management. You would have
yeah,
an all hands on deck situation where you'd have all your software engineers just stop everything, just stop in everything, going through the entire code to make sure that there is no sort of way that somebody could exploit it, and write in systems on top of new systems, to sort of block people from sort of exploiting their code if they ever had issues like that. I mean,
yeah,
this code, they don't explain sort of the so it says the entirety of Twitch and its commit history, but they don't explain like how in depth this was. So for example, most companies nowadays, they have infrastructure as a code and stuff
hmm,
like that. So if people had infrastructure as a code, and if they
yeah,
had
yeah.
the if they could see the files for infrastructure as a code, you would basically
Even
have
the
your
database
SSL
structure, right,
certificates.
David? Even the
Exactly.
database structure is
You'd
so
see your
important.
migration tables,
Yeah,
your for the databases. You'd see your you'd see your SSL certificates. You'd see your secrets in your in your commit as well. And that is super scary. I mean, I
yeah.
I can only empathize with the software engineers at Twitch right now, because they must be going through hell to sort of
And
patch
it's
everything
more
up
like
and fix them.
the entire sort of, let's say, if it's a house, it's the architect's what do you call the drawing, the map, sort of like the map to the entire house. So it's gone, and it's not like they can change the lock in the door. It's just like they had to do the entire house sort
Exactly.
of
From the foundation up. Yes.
foundation. Yeah, yeah.
That's
So
horrible. That's crazy. So yeah, I mean, so let's see what it includes. So the leak includes 3 years worth of details regarding creator payroll. So it's like some payroll stuff, entirety of Twitch.tv, with commit history going back to its early beginnings. Okay, so the entire website, I think, with all their microservices and all their maybe if they had monoliths, their monoliths and all that stuff. Source code for the mobile, desktop, and video game console Twitch clients. Wow, code related to proprietary SDKs and internal AWS services used by Twitch. I'm pretty
Yeah.
sure they might have like AWS secrets and stuff inside this as well.
So like even like Damon, even like let's say if you're doing a small project in the beginning, so Twitch might be a small project in the start, right? So we usually
Exactly,
put everything in the code and just commit in the first few commits.
exactly,
It's not going to be
exactly.
like um yeah, I think they had added a point where saying
They even released Twitch's internal security too. So imagine you have to rebuild all of this, right? I
yeah,
mean,
it's
it's
a
crazy.
nightmare. Yeah. So Damon, do you know like I mean the impact outside of it? Like has anyone done attack yet or not?
I
I
don't
couldn't read
think
anything.
so.
Yeah.
I don't think anybody actually came in and sort of did an attack on it, but I'm pretty sure that Twitch is sort of on a all hands on deck. Like, let's not take any risk. Let's just patch everything up.
So
Let's put
it's
new
an
security
internal leak,
systems
right?
in
I
front.
mean, is it leaked from the
It
inside?
is an inter.
Yeah,
I'm
yeah.
pretty sure. I mean, if you have Git commits, with
It's
commit
like
history going out,
zip the folder and keep in a hard disk or something like that, no?
I mean, this has to be a person with access to some sort of version control system that they have, because let's face it, version control systems are some of the most secure systems in any software company, right? Because
Yeah,
you would only have your software engineers with access to that. You would not have your sales, your marketing. You wouldn't have any of
yeah.
these
Even
teams.
software engineers, we try to limit, right? Let's say if you're breaking the platform into multiple parts, front and back end like that, so
So this
it's
has to be
getting
a
everything
person
together
with
is the hardest.
exactly this.
Yeah,
This
more
has to be
power.
be a person with a huge, like in one of the top levels, with sort of
Yeah,
like close to admin access as much as possible, and who also sort of knew how to sort of use this software engineering sort of stuff,
yeah,
like how to clone a repository and stuff like that.
yeah.
Maybe
Can this
they
be something like a computer? Like let's say we get our computer get damaged and it had all the data in it, and someone else took it out. And I'm just like thinking,
so the,
what
the
can be the cause?
the thing is, this also, I mean, this has I saw somewhere that this has data until like last week, commit history
Oh,
until
okay.
last week, and as well as they had all this stuff like payroll stuff, data on Twitch
The
properties,
content creator, yeah.
yeah, these are like stuff that you don't usually get from, like, if it's a software engineer with a laptop and stuff like that, you won't really
Yeah,
get
yeah,
stuff
yeah,
like this. So this has to be some sort of like premeditated sort of thing.
yeah. Who had
But
downloaded this CSV file or some backup
of
as well?
everything,
Yeah, yeah,
exactly, yeah. But the issue here is that I mean, this has to be someone like at the real, like the top level of stuff to basically do this. And maybe
yeah,
this entire commit history of all Twitch.tv and all the services, this might have also just been a backup of one of their versioning systems as well, because you can just it's just a zip of basically everything in there.
yeah.
Um, I mean, this is crazy. So yeah, the leak doesn't appear to include password or address information on Twitter users, but this doesn't mean this information hasn't been obtained. So basically, the leak didn't include like database dumps, I think,
Yeah,
is what
yeah,
they mean to
yeah.
say.
So and they
Um,
had mentioned like two-factor, like the importance of two-factor and things like that, right?
exactly. So yeah, enabling two-factor authentication.
So yeah.
Um,
But again, if you have the source code, I mean, if you're creating a clone, you can do like true, false, and sort of
it's
pass the boolean
simple.
directly. We shouldn't think that
I
level,
mean,
right?
you can just have your database migration scripts and you are ready to go. I mean, it's super easy to get everything back online. It's not as okay. So it's not as hard as building the thing from scratch.
Yeah, because it's
It's
there,
still a
right?
bit hard, but
Yeah,
not as hard as actually building everything from scratch again.
from scratch. Yeah, yeah, exactly.
Yeah.
Oh yeah. So I think we we talked two negative articles at all. It's not negative. It's more like learnings, right? Learnings from
Exactly.
others' mistakes. So we either
Exactly.
learn or we don't grow.
Yeah.
So
And
yeah,
then there's one more thing that we can just quickly skim over, and this is like an article that sort of came out recently, and this is like from a guy called Justin Etheridge. It's I think it's pretty cool that, I mean, we can just skim over some of the points he has made here, but it's basically 20 things I've learned in my 20 years as
20
a
years.
software engineer. So I think this is something like pretty cool. So um, just a disclaimer here that he's saying You're about to read a blog post with a lot of advice. Learning from those who came before us is instrumental to success, but we often forget an important caveat. Almost all advice is contextual, yet it is really rarely delivered with any context. That's quite true. And let's just see sort of the background he's from. So he's a person who has almost always been on small, lean teams where they had to do a lot with very little. He's a person who values working software over specific tools. Is starting new projects all the time, but also has to maintain a number of systems, and values engineer productivity over most other considerations. So let's just skim through the points that he has made on his blog article. So the first is, I still don't know very much. So after 20 years being in the engineering field, he accepts, I still don't know very much. How can you not know what BGP is? You've never heard of Rust. Most of us have heard these kinds of statements, probably too often. The reason many of us love software is because we are lifelong learners. And I think this is something that I try to tell people whenever they ask me, okay, is software engineering a good industry that I can get into? Is software engineering a good industry in which I can earn a lot of money? I always say yes, you can earn a lot of money, but you should only do it if you are passionate about it. If you have a real interest about it, and if you sort of understand, and you can sort of, if you're ready to basically learn your entire life.
I think, David, it's more like, it's like, are you willing to learn it? I mean, willing to learn it, evolve, right? Sort of like it's evolving, right? Every day. So you can't learn it like on campus and come to the industry and stay in the same place. You have to evolve so much. So I think that's a good advice I think you're giving.
Exactly.
Like, accurate.
That's true.
Yeah.
And let's see, another one that they have is the best software engineers think like designers. So great software engineers think deeply about the user experience of their code. They might not think about it in those terms, but whether it's an external API, programmatic API, user interface protocol, or any other interface, great engineers consider who will be using it, why it's been used, how it will be used, and what is important to those users. Keeping the user's needs in mind is really the heart of good user experience. So what I basically take away from this is, and this is something that I've sort of told a lot of people as well, software engineers are basically like artists. So it's what you make, what you develop is sort of like art at the end of the day, because you're very satisfied with it. I mean, yes, it can evolve. Yes, after 6 months, after 1 year, you might come back and say, okay, why the hell have I done this? This could have been better this way. But at the end of the day, what you develop, and at the end of any given sort of period of time, is sort of a representation of all your knowledge and all the best practices, and basically your approach to software engineering and development at basically that time. So I mean, designing systems, designing and developing, and bringing production, bringing just ideas to work in live production ready code and systems and microservices is basically like, in my eyes, it's like art. It's so beautiful. It's something that when you read a person's code, you can basically understand his thinking process, his patterns, and how sort of he sort of learned and his entire journey up to that point.
Yeah, even after its code level, like how things connect together, right? Like, I mean, architecture level, sort of infrastructure, how things
Exactly.
like talk to each other. So it's all about, I think, it's all connected.
Exactly.
So
another
I
one
think no
is
code one is the cool one, right? So the best code is no code.
yeah,
So
that's a very nice quote. Yes, the best code is no code, or code you don't have to maintain. So yeah, most software engineers are always going to err on the side of writing code, especially when a non-technical solution isn't obvious. The same goes for code you don't have to maintain. Engineering teams are apt to want to reinvent the wheel when lots of wheels already exist. There is a balancing act. There are lots of reasons to grow your own, but beware of toxic not invented here syndrome. So I think this is sort of this is something that all sort of coders and engineers and developers sort of do, is that they tend to basically over-engineer stuff. You think of stuff that aren't probably going to even happen, and you just over-engineer stuff, and then it's too much code, and you can't really maintain it as well, and at the end of the day it ends up becoming like a monolith or some sort of very legacy sort of system. That's really good advice. The best code is no code, or code you don't have to maintain. There was another
So
one
I
that I
think
was just.
just to add to that, Damien, I think it's all about like getting things together, right? Like integration. Let's say, for example, if you want to build a chatbot, there are enough software, let's say dialog flow and things like that. So don't reinvent that part, and then you have to maintain that.
Exactly.
So yeah, it's a very nice thing to
I
having.
mean, if you're a AI or machine learning engineer, you don't want to reinvent the wheel and go and
Of
write a
course,
new
yeah,
package
yeah,
like TensorFlow.
yeah,
You just
yeah,
use
that's right.
TensorFlow, right?
So
Yeah.
yeah, that's true. That's true. Yeah,
So there's this other quote that he says, "Every system eventually sucks. Get over
get
it."
away.
And this is something that I have taken to heart. I've had to rewrite softwares. I've had to re-engineer stuff. I've had to refactor stuff. At any given point, like say you release some sort of code to production, on the day you release it is the best form of code that you have. But in
Yeah,
5 years, there might have been a better way to do it. So, I mean, this is something that my mentors have also told me. This is something that I've seen in real life as well. Any production system, any good quality, like, production system that you are really proud of, would only last for maybe 2 or 3 years. After 2 or 3 years, you are probably going to have to rewrite it all over again because of, evolving protocols, much better ways to do stuff, need for higher latency, need for lower latency, and basically being able to improve the features and stuff on top of it. So basically every code you write is throwaway code, and you have to sort of get over it, and you have to sort of accept that fact and be like, okay, I did the best that I can do, but someday somebody is going to maybe destroy all of this
yeah.
and just delete all of this stuff and rewrite it all again.
I mean, like since my sort of current background is on to research stuff, so this is like the number one thing we had have to follow. It's like not even in the industry. Like it's like let's say we our experiments fail, right? Let's say if the experiment fail, that's basically the end of that code base. I mean, the entire part we'll have to get rid of. So it was so hard for me to like in the first few like months to get over like I mean it's hard. Like we code for like late night and things like that, and then if the experiment fails, that's it, and we have to find new way to do it, or like completely forget about that idea and try again. So yeah, this is really true. Like after you get over it, it's sort of easy to like start from the beginning again. So like start off again, so that's like brand new. So I go and like create new project on PyCharm and just start off a brand new project, so that's always cool. Yeah,
Yeah, that's true. And the rest of the stuff is sort of like stuff about working in like enterprise systems. So I would recommend people like come in and sort of read this article. I mean, it's like stuff like nobody asks why enough. Like you just like if you join a new company, you would just like you would ask why, and someone else would say we've just been doing this the same way all this time. And so you would just go in and sort of follow that same approach. Instead, when you should be more curious, in Sinhala we have this word called kutuhale. So
yeah,
you should always be more curious, and you should always sort of try to find out why stuff are done, and sort of and sort of involve yourself more in sort of what happens. And there's more stuff like um, you need to have ownership. Like programmers need to have sort of a sense of ownership over their code. They should write regularly, keep your process lean. I mean, there's a lot of points here. There's like 20 points here,
yeah.
and I would
I
basically
mean, this is
recommend
like yeah,
everyone to
highly
just come and
recommended.
see.
Yeah, yeah,
Exactly.
yeah. I think yeah, this is super cool. And even just like the 14 point is also like something I figured that it's very cool. Like I mean, it's a must to sort of look it. So yeah, that one. Look for technological sharks. So all technologies that have stuck around are sharks, not dinosaurs. They solve problems so well that they have survived the rapid changes that occur constantly in the technological world. So don't bet against these technologies and replace them only if you have very good reason, right? So I mean, this is
Exactly.
so so correct and so accurate. In like personally, I know that like we can sometimes consider that okay, this is a dinosaur language or dinosaur tech
Like
stack,
Java.
but Java, like PHP, like
Yes.
Laravel, even.
Exactly.
So
Exactly.
uh, sometimes when we look into the architecture and like the stability of those software, we can't actually build up to that level even if you try like 4 years, because that's I think that's again evolvement, right? Like, but if a code is not maintained, let's say for example Laravel, let's say they stop from version 6 or something like that, then that's sort of
Then
going
you have
into the
a
dinosaur
different
direction.
problem. Yeah,
Yeah,
that's true.
yeah.
Yeah,
But
that's
if
true.
it's keep on evolving, it's a shaft, right? It's strong, like getting stronger and stronger, and you can't
Exactly.
actually come up to that level. Yeah,
Exactly. And I think that there's one more point that I have. I don't know if it's in here anywhere, but there's always a tool for the job. I mean, I know people who sort of try to apply JavaScript to everything from front end to back end to infrastructure
yeah,
engineering and all that stuff. And there are people who try to write front ends and serve content using PHP and stuff like that when that might not be so efficient.
the best practice. Yeah,
Exactly, and I see some people using like Java and Spring Boot and stuff like that where they shouldn't. So what my sort of personal sort of opinion here, and one of the things that I've always sort of tried to tell people is there's a place and time to use each and every tool. And as a software engineer, it's your job to know when and how these should sort of be developed. I mean, would it make sense to have your backend in Node.js? Would it make sense to have your backend in another language? Would it make sense to have one sort of database versus another? NoSQL versus SQL, maybe within SQL, MariaDB, Postgres, and all that other stuff.
yeah,
There's always a pro and a con, and according to your situation, you should always evaluate those and select the proper tool. And also, there's this really thing. There's this thing that I have seen among engineers is that they are so focused on sort of one language. So I mean, I've seen developers that say JavaScript is the best. PHP is the
yeah,
best. Java is the best. Node.js is the best. Or basically the Node.js sort of runtime is the best. And I think that's really bad because, again, you should remember these are just tools, and
yeah,
they can get deprecated within 5 or 10 years, and you'll just have to learn something new again. But it's the concepts. It's the concepts that you have that will stay with you forever. Your experiences and your concepts. So I think this is something that one of our lecturers used to tell us. I think I don't remember who, but you should be able to learn, forget, and relearn.
yeah.
I don't
Relearn
remember. I
is it
don't remember who
Guxisa?
told this. I think this is in university, right?
Yeah, I think Guxisa, right? I'm not sure.
Guxi, okay. But this is sort of something that I've always been remembering. Learn, forget, and relearn. I mean,
Yeah.
you should have the skill with you for any
Yeah,
sort of
I mean
programming
the
language.
example I think was something like I think it's again Java. So knowing Java in the industry and then again like coming into the academic field, that Java is a bit different, right? So Java double E, Java C. So you have to sort of forget
Yeah.
about the industry one and then relearn the new ones.
Yeah, but this is
So
something that I've actually been applying for a lot of languages and frameworks on myself as well. So, for
that's good.
example, I I used JavaScript a couple of years ago, but if you told me to implement something in JavaScript right now, it would take a bit of time for me to relearn it again.
Yeah, because
If
it's
I
all
get
evolved, right? Like
it
Angular
all
1 to
evolves.
Angular 2, Angular, I don't know the
I-
version number right now.
It's not just that, but I also sort of forget what I learned because the same patterns that you have in JavaScript, you probably wouldn't have in Java. And if I'm working on a Java project right now, I wouldn't want to apply the patterns that I learned and that I use in JavaScript and stuff like that. So that style of coding and that sort of stuff there. So it's more like you forget about it. Okay, you know JavaScript, you know how to use it. Just push it aside into another part of your brain and just activate. Just turn the switch
Yeah.
to your Java sort of thing there. Or if you're using maybe some other sort of language as well, Rust, C Sharp, C++, Python. I mean, Python
Yeah,
is a really cool example. I use it every day in my personal projects as well. Just switch off your Java, your
yeah,
JavaScript,
that's true.
switch to Python.
I mean, I think that's actually sort of a good thing, not a bad thing, right? So knowing, like doing many different languages in a day is also like very sort of like it triggers your brain a bit. Like it's giving some work to the brain. Otherwise, you are just focused on one. So for me also, I do the same. Like university time, it's Python. Then after work, it's like Node.js or something. Then again PHP at night. So it's a whole different combination. So, but yeah, as you said, like you just need to figure out okay, how to do that quickly and sort of rapidly and move on. So that's very
Exactly.
true.
I don't really understand why some people say, okay, JavaScript is the best language. Everybody should learn JavaScript. I mean, that's stupid. I mean, everybody should learn everything,
Yeah,
and
it's
you should learn like the pros and cons of
because
each of
as
these. And
yeah, as software
yeah,
engineers, that's the only thing you can like that's the space, right? So for let's say
exactly.
for a let's say someone who reads books and stuff like that, they have enough books like different genres like that, but we have like languages end of the day, like programming languages to choose from. So the
Exactly,
more you
that's
know,
true.
the more you get the principles of core software engineering. Yeah. So I think we
That's
had a
quite true.
nice chat. Overall, it's well balanced. Um, two negative stories and one highly positive notes.
Exactly, ways on which we can improve and stuff like that. But
Yeah.
I would totally recommend everybody to go ahead and read all of the articles that will be linking below in the description as well, because I mean, these are like food for thought basically, like how we can improve ourselves as well as the systems that we use and the systems that we develop on top of. Yeah, I think that's all we have for today actually,
Yeah.
and I guess we will see you guys maybe next week or maybe sometime sooner.
Yeah, just adding the
Depends
maybe
on
just to be safe.
may, it depends on if there's a global outage again. Fingers crossed it won't happen, but yeah, let's see what happens. And basically, I think we'll see all of you guys quite soon, right, Saman?
Yeah. Yeah. See you guys then.
All right, cheers and have a great week.